All right, 1993, AB4. Let f be the function defined by f of x is the natural log of 2 plus sine of x for x is greater than or equal to pi and x is less than or equal to 2 pi. I would note that we have a closed interval here, and so I would expect to be asked about absolute minimum and absolute maximum values, and lo and behold, in part A we are. So we're trying to find the absolute maximum value and the absolute minimum value of f. Show the analysis that leads to your conclusion. Now you don't need to state what I'm about to state, and I will tell you the minimum amount that you need to write to satisfy this. And however, the absolute min and absolute max are tied to what is called the extreme value theorem. And we can call that EVT. The extreme value theorem states that a continuous function on a closed interval always has an absolute min and an absolute max. That is the extreme value theorem. Now, where these occur is what is important to us. Absolute min and absolute max under the extreme value theorem always occur at critical numbers and endpoints. So whenever the extreme value theorem holds, that means we're working with a continuous function on a closed interval, which we are, then the absolute min and absolute max have to occur at critical values, critical numbers, or endpoints. Now, we did see that we're working with a closed interval. We should really test to see that we're working with that we are indeed working with a continuous function. And the way we would check that is to note that the inside of the natural log function, the only restrictions on the natural log function are that the values we give to it must be positive. So 2 plus sine x will always be positive because sine has a value between -1 and +1, and so even at its lowest point of -1 we're still going to add 2 to that, and so it will always be positive. So we will always be taking the natural log of a positive number, and so hence it is a continuous function that we're working with, and we are also given a closed interval. It's a continuous function actually for all values of x, and since we're given a closed interval, we know that the extreme value theorem holds, and so absolute min and absolute max values will occur at critical numbers or endpoints. So we need to find the critical numbers. So we will find the critical numbers and the endpoints. We will evaluate the original function at those points. The lowest will be the absolute minimum. The highest will be the absolute maximum. Okay, then let's get started finding the first derivative of that function. Since this is function composition and the outside function is the natural log, the way we find the derivative of the natural log is 1 over x. And so if it's a function composition, it will be 1 over whatever. So the derivative of the outside, leaving the inside alone, is 1 over 2 plus sine x. Now we need to multiply that by the derivative of the inside, which you should see is just cosine of x, and then the final form is cosine of x over 2 plus the sine of x. Now, for there to be a critical number must be a place where that is 0 or does not exist. And a rational function is 0 when its numerator is 0. So it will be 0 whenever cosine of x is 0, and cosine of x is 0 at x equals pi over 2 and 3 pi over 2, but in the interval that we're looking at, only 3 pi over 2 holds. So that is the critical value. That is the only critical value that occurs when the first derivative is 0. Then we also need to check to see whether the derivative doesn't exist anywhere. And we just applied the reasoning that because sine of x has to oscillate between -1 and +1, 2 plus sine of x will never be negative and it will never be 0. So x equals 3 pi over 2 is the only critical value for that function. Then we're going to test the original function at those two values, or at the critical number and the endpoints, and find the lowest and highest. And we'll pick that up in the next video.